In this video, I'm going to talk about something very important. It's called implicit differentiation. Okay, implicit differentiation. Now, as with all of my videos, I don't really care about the name. I don't care if you cannot pronounce implicit correctly. It really doesn't matter. What you need to know is what in the world is this, and how is it used, and when is it useful. Okay, this is known as implicit differentiation. Let me explain when you need to use it. If you look at the two equations I give you here, you might get a better idea. So let's say I want you to differentiate the first equation. Okay, differentiate this. It's quite easy, right? dy dx equals to, I bring down the 2 times 3, I get 6x. That's the answer. I'm done. Now what you need to understand is, how did we get this dy dx here? What I did is I took y and then I differentiated it with respect to x. So in English, I take this y, I differentiate it, I'm just going to write diff, differentiate it with respect to x. This will give me dy, differentiate y with respect to x. So I differentiated the y with respect to x. Okay? What I'm doing is I'm actually differentiating the entire equation with respect to x. So when I differentiated y with respect to x, I get dy dx. What happens when I differentiate x with respect to x? X differentiate with respect to x. You guessed it, I would get dx over dx. There's no need to write this because dx over dx is simply equals to 1. You can see it cancels out, right? Dx over dx is equals to 1. What am I telling all these things for? It's important because this is what leads on to the next portion. Okay, take a look at the equation on the right. I'm going to draw a line in between here to separate these two. Take a look at this. This equation here, I have y squared plus y equals to 3x squared. And I want you to differentiate this equation. And then you'll be faced with a problem. The previous equations always had y on one side and nothing else. Everything was on the other side. Now I have y on one side, I got another y squared on one side. And I'm not sure whether I can still differentiate this the same way that I used to. The answer is you cannot. You cannot do it the same way anymore because now I have two y's here. Okay, making this a bit more complicated. So what I need to do is, I need to differentiate the same thing I did here. I'm going to differentiate the whole equation. And I'm going to treat the y just like as if they were x. Let me explain this very, very quickly, okay? What happens when I differentiate y squared? Imagine if it was x. What I'll do is I'll bring down the 2, okay? I'll bring down the 2 to become 2y. Am I correct? What happens when I differentiate y? Imagine if this was x. If it's x alone, what I will get is 1. Okay? Differentiate this is x, so 3x squared, I differentiate this, I bring the 2 down, I get 6x. Yeah? So it looks almost the same as what we did just now, except that now these are y, right? And because I differentiated the y with respect to x, every time a y appears, I need to write dy dx behind. So this one, I differentiated this, I must write dy dx behind. Okay? Let me repeat that one more time. Every time I differentiate something that is a y, okay, for example, I differentiate this, I would get 2y, and I must write dy dx behind. Okay, as long as the alphabet, this alphabet, is not the same as this alphabet, I must write this. Okay, dy dx. So one more example. This one here, I'm differentiating the y. If I differentiate y, I will get 1. But because this, I'm differentiating y with respect to x, I must write dy dx. Okay? So let me continue. From here, what do I need to do? The aim is find dy dx. And I notice that I have one dy dx here, I have another dy dx here. And this now becomes an algebra equation. Okay, so I'll factorize out the dy dx. I got one here, I got one here, I'm going to factorize it out. Dy dx. What's left here is 2y. What's left here is plus 1. Okay, equals to 6x. You can see that if I move this down here, I would be left with dy dx equals to 6x divided by 2y plus 1. And this is my answer. Okay, this is my answer when I use something known as implicit differentiation. This step here is called implicit differentiation. You remember it when you differentiate something other than x, you got to write this behind, dy dx behind here. Okay. In the answer, you will notice that there is a y. Okay, your answer is not completely made out of x, there's a y here. This is okay. It's okay to have the answer with a y inside here when you do implicit differentiation.